There is enough people already, or shall we wait a bit? Okay, so we will start. So, hello everybody. I'm Rosa Mosquera from the University of Santiago de Compostela. I am one of the co-chairs together with Ladislao and Hero Gollany, our presenter today. We are co-chairs of the Global Research Alliance-Croplands Research Group and working for, as you know, for trying to develop initiatives to mitigate and adaptate to climate change. Our presenter today is Hero Gollany. She has a master or PhD in agronomy obtained by the South Dakota State University. And she's a very important expert on the influence on carbon and nitrogen dynamics and cycling, and specifically studying interactions with the soil water plant air continuum using process-based model. He's part of the IRS project known as GrassNet, where she's trying to develop and measure some soil carbon, organic carbon, and greenhouse gases emissions in 6 different cropping systems. She's also an expert on the CQESTR model. Well, she's going to have a presentation today as an excellent presenter. So, Hero, the floor is yours. I think it could be well good if you are able to share your screen. I also would like to say all of you that if you have any questions, please include it in the chat, and we will ask her at the very end of her presentation. The title of the webinar is Predicting Soil Organic Carbon Dynamics in Long-Term Agricultural Experiments Using the CQESTR model. Thank you for being here, Hero, and the floor is yours.
Thank you for the invitation to speak on soil carbon. And good morning, good afternoon, good evening, wherever you are. I will start the presentation. Hopefully share my screen and let me know if you can see my screen. Okay, great. So I will, title of my presentation is Predicting Soil Organic Carbon Dynamic in Long-Term Agriculture Experiment using the CQESTR model. Models are very relevant now because carbon models are needed to predict long-term effect of management practice on soil carbon and soil organic matter, and to estimate the benefit when considering alternative management practice. First, I will introduce you to CQESTR model, then to its application in long-term experiment. I'll cover a brief description of the model that we developed here in Pendleton, originally for Pacific Northwest region, and we have modified to be used across North America. It computes rates of biological decomposition of crop residue or organic amendment as they convert to soil organic matter in each soil layer up to 5 layers or 5 horizons. Rate of decomposition is a function of nitrogen content of the residue, water content, biomass type, soil texture, and drainage classes, and temperature, of course, or thermal unit. unit called cumulative degree day. As amendment or plan residue decompose, it goes through decomposition phase, decomposition phases. In phase 1, after 1000 cumulative degree day, or thermal units approximate the readily oxidizable substrate. In phase 2, we after 15,000 cumulative degree day, the plant material is in a slow decomposition phase, representing oxidization of more recalcitrant. In phase 3, composted material will be transferred into the soil organic matter pool after 15 cumulative degree day. We recalibrated CQESTR using 6 long-term experiments across the United States and Canada, from South Carolina to Alberta in Canada, from Ohio to Oregon and Nebraska, and also several other sites. Also, we validated the model, using regression analysis of measured and predicted soil organic matter under diverse climates, soil texture, drainage classes, and agronomic practice at the 13 long-term agriculture site had a range of soil organic matter resulted in very significant, excuse me, I think I need to turn off the notifications on my computer. Sorry for the interruption. We at the 13 site, linear regression with R square of 95 was obtained, and this was very successful recalibration and validation. CQESTR can be used to consider a wide range of scenarios, such as residue removal, cover cropping, integrated crop, livestock, before making a recommendation or implementation of proposed change. From now on, only points are the measured data, and lines are simulated soil organic matter or soil carbon. At CBAR, Columbia Basin Ag Research Center in Pendleton, Oregon, CQESTR predicted decline in soil organic matter for fertilized and for the residue-bearing plots. However, manure, as you can see, sustained the soil organic matter in the top 30 centimeter, but it didn't in the 30 to 60 centimeter plot, in the plots where we had measured soil organic matter. CQESTR also used at Columbia, Missouri, Sanborn Field in Missouri, the famous long-term plots. And here, as you can see, a rapid decline in soil organic matter in top 20 centimeter when the fields or native tall grass prairie was converted to continuous winter wheat when 90% of the straw was removed. But when after straw retained soil organic matter start to gain back. At Florence, South Carolina, on a sandy loam soil, simulated 60% crop residue removal decreased soil organic matter. Soil organic matter by 21% in the top 5 centimeter and by 90% in the 5 to 10 centimeter depth and by 13 in the lower horizon. The predicted decrease, it was very significant at the site. In Champaign, Illinois, also we looked at residue removal, observed and simulated trend at Morrow plot indicated rapid decline in soil organic matter after conversion and 90% stopover removal. We estimated soil organic matter maintenance required for this site, and we estimated that at Morrow a minimum of 8 megagram per hectare per year of crop residue and 4.6 megagram carbon per hectare per year organic amendment was required to maintain soil organic matter. Here is a predicted annual biomass input for another site in Morris, Minnesota. The residue required at this site was about 3.75 megagram carbon per hectare per year to maintain this site until 2035. That's the simulation period we used till 2035. This site, they had different tillages, the conventional till, as you can see, it's very low in organic matter, which and they were removing the residue. Only the no-till that started in or initiated in 2006 was had positive soil organic matter. Now I will be switching gears a little bit. We will go south to Brazil, and we will look at the plots that's in integrated crop livestock system. scenario, and we our objectives here was to simulate um, future management effects on this farm, which was initially in forest, but it was changed to selective logging in 1950, and then they completely deforested the site in the 1970s, and they start cropping system in this area since then, and different cropping system being used. Can you hear me still? Okay. I just I didn't know if you can hear me. So at this site, our objectives were, before we move on, I will call this integrated crop livestock management in paddock 4, which started in 2001, and paddock 5, which started a year later. The objectives were to evaluate the predictive performance of CQESTR model for a tropical savanna, and second, to examine the effect of integrated crop livestock scenario on soil carbon stock. P4 included 2 years of soybean, dry rice, and corn, followed by 3.5-year pasture. P4 was corn and followed by 4.5-year pasture. Measured and CQESTR simulated value were significantly correlated with the mean square deviation of 7.5, indicating that the model captured spatial temporal soil organic carbon at the sites under the Brazilian climate. Here is the predicted performance that we predicted the soil carbon increase by 12.404 megagram at the rate of 60 megagram per hectare per year under current management by 2030. Cropping followed by 3.5 year pasture. And here is for paddock 4, prediction was increased, the soil organic carbon increased by 18 megagram per hectare at a rate of 90 megagram per hectare under current management. And paddock 4 had more time in pasture. That's why we have such rapid increase. It was 4.5-year pasture versus the 3.5-year pasture in paddock 4. Climate system is adaptation to anticipate impact of climate is a pressing issue facing agriculture. As precipitation and temperature changes are expected to have a major effect on agriculture production in many regions of the world, These changes will have effect on soil organic matter and consequently decomposition of associated soil carbon stock, which have the potential for feedback to climate change and affect agroecosystem resiliency. Most of agroecosystems have a potential to store carbon through improved management. However, there are also limitations to improve soil stock, particularly under dry land condition. Unless crop yield and crop biomass increase under projected climate change. We have several long-term plots that I will share with you. Notable fallow NTA that started in 1982 and notable wheat fallow NTB that started in 1997. Then I changed this wheat fallow rotation to wheat pea cover crop in 2010 and conventional till that is multiple plow tillage in our region. So here is another long-term plot, GraceNet plot we have. I will show you here just the graph. Here is our wheat, after wheat or continuous wheat under no-till. Then we have wheat Sudan, also under no-till. The difference between these two, this has only 3 years, 3-month fallow, and this one has a 9-month fallow. Then we have wheat, fallow under sweep tillage and or under mobile plow tillage, which is these. And we have also, I started a blank, which is, I call it a blank. It's a continuous chemical fallow. As you can see, we continuously use glyphosate to terminate any plant. As you can see how fast we are declining the soil organic carbon in the soil profile. This started in 2004 and we are about here now, 2020, and we are expecting to really reduce carbon in these plots. So we simulated soil carbon till 2050, and we 52 actually 2052, and we, as you can see, the only cropping system is our continuous wheat under no-till, and second best is our wheat Sudan under no-till. The rest, any wheat fallow, we are losing soil organic carbon, and it's not sustainable. So I will be talking a little bit about RCP 4.5. For those that you are not familiar with the terminology, here is RCP 4.5 is a pathway assuming greenhouse gas emission decline following mid-century peak, and RCP 8.5 If it assume that we keep emitting gas, and we will not reduce our rate of emission and continue to through 2100. I use those terminology soon, so that's why I am going to go through these plots with the prediction under both RCP that was at 4.5 and 8.5 for our plots. In case we see a really busy table, so that's why I wanted to make sure you have that definition before I start talking about the RCP 4.5 and 8.5. So this is a description of the our nodal A, nodal B, and conventional TEL. And nodal A, we have 0 and 135 kilogram per hectare nitrogen rate, and so is the nodal B, which is the wheat P, and our conventional TEL also with the same rates. Next slides is a busy slide, but you don't need to really look hard. Only look at where you can find a positive sign, because in this crowded table, you need to bear with me just explaining a few things that I need to concentrate. I need you to concentrate on number, just not on numbers, but just on the sign before the numbers. At Pendleton, Oregon, under Mediterranean climate, all treatments in the wheat fallow rotation losing soil organic carbon in the top 60 centimeter with 0 nitrogen application rate under current climate, and both RCP 4.5 and RCP 8.5. Only nodal B is a positive sign. As you can see, this was with a 0 the nitrogen fertilizer, but P is compensating for the nitrogen fertilizer, and only on the top we have a positive top 0 to 30 centimeter. We have a positive change in soil organic carbon. Now we move to even the other nitrogen rate, 135. As you can see, for conventional TEL, we are losing soil organic carbon throughout all the under climate change and under RCP 4.5 and 8.5. As you can see here, we have wheat fallow with 135 kilogram per hectare nitrogen it improved under decent prediction increase in yield. But as you can see, under the average yield, it's still negative in the soil profile, but under decent yield projection, we can increase if the we can increase the yield. So the only positive, excuse me, positive is this wheat pea rotation under the 135 kilogram per hectare nitrogen fertilization rate. Now we move to simulated change in soil organic carbon for 2004 through 2094 period at State College in Pennsylvania. They have different cropping system there. Also, they have different precipitation, as you can see from this graph. From that, the highest is when you have dairy forage no-till with manure added, and second highest was the dairy forage with under no-till with manure added and rye cover crop. Also, this is for corn, soybean. You can see under no-till we can have increased in soil organic carbon during that 90-year period, and also under but only on the topsoil 0 to 10, but from 10 to 100 we are losing carbon, although we have a positive in the whole soil profile. Next, under the worst climate scenario, which was the continue emitting greenhouse as usual. Here you can see still dairy forage, no-till manure added had high soil organic carbon still, and dairy forage, no-till manure and rye cover crop also had still positive by the end of the century. So both dairy forage conventional till and dairy forage no-till were positive, but as you can see, the corn soybean will be losing carbon, although in the topsoil we have positive carbon input. Also under corn soybean, under no-tills with the stover removal, still we are losing carbon in this profile. We have corn soybean no-till is positive a little bit comparing to when they are moving the stover. So in conclusion, response of soil carbon to climate change were affected by local climate, agroecosystem production type, properties, and level of conservation agriculture practice. including cover crop under no-till, native perennial grass, or alfalfa were the best practice at these sites. Wheat fallow under no-till cannot sustain soil carbon unless wheat yield increased under projected climate change. However, wheat cover crop under no-till increased soil carbon under current and projected RCP 8.5 under Mediterranean climate. Dairy forage under no-till with or uh, without manure are more resilient practice than grain, corn, soybean, or dryland rice. And organic inputs such as manure with high recalcitrant carbon content are key strategy for maintaining or increasing soil carbon and improving resiliency of agro-system to the projected climate. Thank you for your attention. I hope you have few questions for me. And these are the references which also I'd like to acknowledge several people who worked on these data, and I appreciate their collaboration and inputs to this. So with that, I think I will turn it over to you.
Thank you very much, Hero, for your excellent presentation, and thank you very much for being here because I know it's quite early in the States. Thank you very much. Yes, we have several questions and comments. Well, one of them is thank you very much for the presentation. But the first question is from Famuddin Agus, and the question is: did you measure soil organic matter or soil organic carbon? And what was the analytical method?
Okay, well, it depends on the site. For us, we measure soil organic carbon, and I really clean up all the residue in the soil. I have published a paper about effect of residue in the uncleaned soil when you are measuring soil organic carbon. The sites, the long-term sites were all in soil organic matter. So and I reported in soil organic matter. And that's probably is loss under ignition. That's what it was done in the past, because some of these sites about 100 years old. Actually,
Yeah.
Moro is over 100 now, Moro plots. So we didn't have the technology or knowledge of soil carbon now. But also in Brazil, it was soil organic matter was measured, and we that's what was available because it's a long-term site, and they started when they didn't have the carbon analyzer like what we do today.
Yeah.
So
Well,
yeah.
ancient times. Thank you very much.
Welcome.
The second question is from Marcelo. He's from Argentina, and his question is about what is it? What is wheat for? Is it for commercial is used as a commercial crop, or it was used as a cover crop?
Which one?
Wheat.
Wheat? Oh, wheat is our wheat is for consumption, for making bread.
Okay.
So,
So it
yeah,
was a
it's
commercial
not
crop.
covered. No, yeah, it's a primary crop actually in our region. We have, yeah, that's why we are working with wheat, and I am trying to modify it with cover crops such as pea to reduce nitrogen footprint
Okay.
in from fertilizer.
Yeah.
So if we could reduce the nitrogen input, we could improve the soil and the gas emission from manufacturing nitrogen fertilizer or carbon footprint of fertilizer is high.
Okay. Thank you. Thank you very much for your answer. The last question that I have in the chat, I don't know if there are more, just please write it, or at the end I will open the floor just for any of you that wants to make any comment. The question is, how are solid hydraulic properties, water retention, hydraulic conductivity represented in the CQEST? Can their parameters be varied in the model over time?
Yes, we have drainage. Uh, Actually, I think I could go back to input required for the model. I could put it up. I thought uh, it's the crop rotation and tillage information, which is grain and residue yield, the root biomass, an amendment such as nitrogen from manure and nitrogen content of the crop, soil type, timing, and all that goes into Russell C factor file. Also, we need monthly average air temperature and precipitation and information on soil thickness and initial soil organic matter and bulk density
Mm-hmm.
and other information. Also, I could show you, I knew somebody will be asking what are the um, decomposition model that's in the it's used in the CQESTR. It says we have the nitrogen factor, K factor, and also we have which is the universal decomposition rate and water availability. Different drainage class has a different effect of on the soil organic carbon, also soil texture. The site in South Carolina, Florence, was a loamy sand, and the one in Brazil was clay soil. So drainage and soil texture has effect, and I hope this answer the I should end that. That's what I hope that was the question for what goes into the model.
Okay, thank you. I think that the next one is almost answered, but if you want to add any other aspects, it said the question is from Comlan Rene, and is I would like to know if models takes into account the influence of anthropogenic activities on soil organic matter. I think because you added nitrogen, I guess yes, but if you want to add anything else.
Yeah, yes, it does affect nitrogen. It will affect organic matter, and Also, other factors is I think drainage is very important because of the decomposition
Yeah.
factor. I hope that answer
Yeah, yeah.
his
So,
question.
so there is another question. There are many questions. We're very happy about that. Because I mean, it means that your presentation just increase it gives a lot of awareness about your topic. So the next one is how is it the initialization of the model? Do you have to run the model until the soil organic carbon steady state before the modern phase? And it's done by Marcio.
Yes, we do back calculate and then forward before we start simulating the carbon in the at the current um, dates, then forward for prediction in the future.
Okay. Thank you. And the last question from Marcelo, is it in the texture factor, can you select different types of clay or the type of clay?
No, we don't have that factor. I was hoping we get some collaboration going on with Brazil because they have different type of clays. Also, another issue I been thinking about iron oxides in some soils could affect binding of organic carbon, and we don't have those two factors, especially for highly oxidized soils.
Yeah.
We need to consider that, but I don't have highly oxidized long-term plots around here. So if he has it, we could collaborate and see if the models still function in his plots, if he has long-term plots.
Okay. Thank you very much. Hiro, I think there are no more questions. I just want to announce that we will keep going with different webinars from now. Also, I would like to explain that we, from the Global Research Alliance Global Research Group, are aiming at developing a agroforestry flagship, just in case you are interested. Also, in case you are interested to participate in webinars, just please send us that information to any of the co-chairs. Also, yeah, any comment, any paper that you want to publish in the newsletter. Before ending, because I don't see any further question, I would like to just give a big applause to Hero for
Thank
the
you.
for the for the excellent presentation you did, and for the rest, I hope to see you in Seville, Spain, in the conference of agroecology, the mid of January. I don't know if you want to make any other comment, Hero, Javier.
No, thanks.
Okay,
Yeah.
okay. Yeah,
Well,
thank you. Mhm.
thank you both for organizing this and for inviting me to give this presentation. I appreciate your effort to arrange for this early meeting.
Thanks,
Thank you.
thanks a lot for the effort. And thanks, Javier, also. And thanks to all of you for being there. See you next time then. Bye.
Bye.